Dam, a structure placed across a river, an estuary, or a stream to hold back water. Dams are constructed to store water for use in industrial processes, human consumption, and irrigation of semi-arid and arid terrain. They can be used to increase the volume of water available for hydroelectric power production, decrease the peak discharge of floodwater brought on by intense storms or rapid snowmelt, or raise the depth of water in a river to facilitate easier navigation for barges and ships. Additionally, dams can create a lake where people can go boating, swimming, and fishing. Many dams are constructed to serve many functions. For instance, water in a single reservoir may be used for irrigation, hydroelectric power generation, and fishing. Such water control devices are frequently referred to as multipurpose dams. Spillways, movable gates, and valves that regulate the discharge of extra water downstream from the dam are examples of auxiliary works that can aid a dam in performing properly. Dams may also have water intake structures that supply water to a power plant or to canals, tunnels, or pipelines intended to transport the water the dam stores to far locations. Other auxiliary works include fish ladders, graduated stairs, and other tools to help fish that are trying to swim past or around a dam. Systems for evacuating or flushing out silt that collects in the reservoir, locks to allow ships to travel through or around the dam site, and more. A dam can serve as the main building block of a multifunctional plan created to conserve water resources on a regional scale. In developing nations, where a single dam may deliver important benefits linked to hydroelectric power production, agricultural expansion, and industrial growth, multipurpose dams can be especially beneficial. However, owing of their effects on riparian habitats and migrating fish, dams have come under increased environmental scrutiny. Large reservoirs can also flood huge areas with a lot of people living on them, which has led to opposition to dam projects from groups who don't believe the advantages of the proposed dams outweigh the disadvantages. Dams can be categorized in terms of engineering into a number of different groups based on their structural design and construction type. Which sort of dam to be constructed largely depends on the valley's foundation conditions, the construction materials available, the site's proximity to transportation networks, and the qualifications of the project's engineers, financiers, and promoters. The three most common materials used in modern dam engineering are concrete, earth fill, and rock fill. Although jointed masonry was once used to construct a number of dams, concrete has mostly taken its place and rendered jointed masonry mainly obsolete. Massive gravity dams, delicate arch dams, and buttress dams can all be constructed out of concrete. High-quality concrete can now be put using the same machinery that was first designed to carry, distribute, and consolidate earthfill thanks to the development of roller, compacted concrete. Because they consist of enormous mounds of dirt and rock that are constructed into imposing man-made embankments, earthfill and rockfill dams are typically classified together as embankment dams. The earliest known dam is a masonry and earthen embankment at Jawa in modern-day Jordan's Black Desert. In order to increase irrigation production on downstream arable land, the Jawa Dam was constructed in the 4th millennium BCE. Its purpose was to retain the waters of a small stream. Another masonry-faced earthen dam that was constructed around 2700 BC in Sad el Kafura, in Egypt, some 30 kilometers (19 miles) south of Cairo, has been documented. The Sad el Kafura washed away shortly after it was finished because it lacked an erosion-resistant spillway and was overwhelmed by a flood. The Orontes River in Syria has a rockfill embankment about 6 meters (20 feet) high that was constructed around 1300 BCE for local irrigation use. It is the oldest dam still in operation. The design of dams made of concrete and masonry is based on traditional structural theory. Two phases in this relationship might be discernible. The first was actively concerned with the precise profile of gravity dams, in which the horizontal thrust of water in a reservoir is resisted by the weight of the dam itself and the inclined reaction of the dam's foundation, and it lasted from 1853 until around 1910 and was represented by the contributions of a number of French and British engineers. Engineers started to realize, however, around 1910 that concrete dams are monolithic, three-dimensional structures, and that the distribution of stresses and deflections at any given point within a concrete dam depend on the stresses and deflections at a large number of other points within the structure. Every movement must be compatible with every other movement at every other place. At the turn of the 20th century, concern among the general public grew over the impact of dams on the environment. Fears that dam development was harming fish populations that were migrating or spawning, which were being obstructed or hindered by the construction of dams across rivers and waterways, provided much of the fuel for this anxiety. See fish passes below. In a broader sense, dams were frequently seen as obliterating the environment and massively destroying flora, animals, and scenic landscapes in addition to altering the environment to satisfy human demands. Dams were also held responsible for the flooding of native peoples' ancestral homelands after they were forced to leave the reservoir take zones built by large-scale dams. None of these issues emerged overnight. Rather, they all have origins that go back many years. Dams are still regarded as a significant source of agricultural water and hydroelectric power in developing regions of the world. However, the environmental costs of dams have garnered attention. India saw strong political opposition to several dam projects as a result of the eviction of hundreds of thousands of residents from reservoir areas. The Three Gorges Dam in China, built between 1994 and 2006, sparked fierce criticism both domestically and internationally. The reservoir that was built after the construction of the 300-meter, 500-foot long, 185-meter, 607-foot, high concrete wall across the Yangtze River caused millions of people to be relocated and cultural and natural riches to be lost behind it. One of the greatest hydroelectric generators in the world, the dam is capable of producing 500 megawatts of energy, which can reduce the consumption of coal by millions of tons annually. Without a doubt, dams continue to play a significant role in the global social, political, and economic system. But for the foreseeable future, there will undoubtedly be heated discussion over the details of that function and how dams will interact with the environment. The two main types of modern dams are embankment, earthfill or rockfill, designs, and masonry, concrete, gravity designs. Masonry dams are frequently used to block streams that flow through relatively small gorges, such as those found in mountainous terrain. Although the structures may be extremely tall, only a small amount of material is generally needed for such sites. When controlling rivers and streams that flow through vast, open valleys, embankment dams are frequently preferable to very long, material-intensive barriers. The site's geology and configuration, the dam's intended uses, and financial considerations relating to material availability and site accessibility all influence the design option. So share your views with us about dams in the comments section below. Moreover, subscribe to our channel for future updates.